All right, so I think we're good to go. We are up and running. All right, I think we're good to go. We are up and running, please. Let's consider set theorem for today. All right, so welcome to today's class. For today's class, we consider set theorem. As I said, it's my first time with you, and we'll do an introduction much more later. Time is already fast spent. So let's just dive straight to the business of the day, okay? So do something called set theorem. Basically, I will give you definition, and I'll walk you through everything you have to know about set theorem. And then if there's time, we'll solve some past question, and that's it for the day, okay? Let's do set theorem. Before then, let's do something. Let's do something. I want to mention some stuff, and I want you to follow me up. I can call 2, 3, and then you help me complete it. So let's go. All right. So first things first. Let me start by saying Umuahia, Yola, Bauchi. Tell me something. What should be next thing? Huh? Makodi. Listen, oh, listen. Listen. I said Umuahia, Uyo, Yola, Port Harcourt. Now tell me something. No. No. Sorry? Bauchi. I mentioned Bauchi now. Yenegua. Good. Enugu, yes. Sokoto, Kogi. What else? What do you think I'm saying? What do I mean? Huh? Not just capital of states, but what? Capital of states in Nigeria. That's what I'm doing. If I say Uyo, that's for what there? Kwabom, right? Yes. If I say Umuahia, that's for what there? Abia. Now, how is it that I never mentioned I was going to say the capital of states, but you were able to figure it out? Why is it so? That's what the concept of sets come in. When you're given a set of things, they might not tell you what it means, but you should be able to figure it out. Why? Because what you have there are defined. Fine. Let's look at definition, please. Definition, set theorem. Definition, please. Set theorem, definition, please. A set can be defined as a collection of well-defined items. A collection of well-defined items. A set is a collection of well-defined items. We'll stop. The items that make up a set or the elements of that set. The items that make up the set are called the elements of that set. So we can define a set as a collection of well-defined elements if you want to. Right. A collection of well-defined terms. And I said the terms that make up a set are called the elements. That's basically. All right. Next up, please. Let's look at something called set notation. Set notation. Let's look at something called set notation. Set notation simply tells how a set is being represented. Set notation simply tells how a set is being represented. Set notation simply tells how a set is being represented. In essence, when we say set notation, we also mean set representation. So set notation and set representation are the same thing. So in this case, we're using the word notation and representation synonymously. So if I say set notation, I mean how do we represent sets? There are two ways of representing sets. There are two ways of representing sets. representing sets. If this goes up, let me know. Right? There are two ways of representing sets. Number one, by set builders notation. That's the first one. Then number two, by listing. There are two ways of representing sets. Number one, by set builders notation. Number two, by listing. So most likely your test on your exam or whatever place you see sets, you represent sets in two ways. Number one is called set. First one is called set builder notation. The second is called listing. What's the difference? Take down, please. What's the difference? Take down, please. What's the difference? Take down, please. Let's define set builders. Set builders notation. Let's define set builders. So first things first, please. Set builders notation. First one there. Set builders notation. This involves the description. This involves the description. This involves the description of a set using words. This involves the description of a set using words. This involves the description of a set using words. Full stop. That's all. So when we say set builders notation, it simply means describe a set. That's all. Now, for instance, look at this, please. Let's say I have something that looks like 2, 4, 6, 8. This. How do you describe this? Huh? Even numbers. Now, that's not correct. Out of 100, if you say even numbers, I'll give you 10, just because you know even numbers. We'll write even numbers, but whichever we do, I'll just give you a 10. That's not really correct. Why? Look at how we define sets. I said a set is what there? It's a collection. In quotes, hold on, the emphasis is on the term well defined. Well defined. If you say this is a set of even numbers, so I will just call somebody from there and say, please come and write even numbers. The guy comes here and writes 30, 40. Is this correct? Hold on. Are these even numbers? Yes, they are even numbers. So you can't call this even numbers because even numbers can be 30, can be 100. So far as the number can be divided by 2 without a remainder, it's an even number. Now let's go back to this. Look at this again. What do you think you can define this for it to be correct? A set of even numbers, less than 10. Even numbers less than 10. Okay, that's one. What again? Less than or equal to 8. Okay. Now listen. When you go higher in science, there are some things you know that will scrape it off and use mature terms. For instance, the basic guy doing JSS1, they will tell them that in JSS1, when you're doing weight equal to mass times gravity, we'll say weight is equal to mass times gravity. In JSS1, gravity is what there? 10 meters per second squared. In JSS1, gravity is what there? 10 meters per second squared. But when it comes to SS1, it becomes what there? 9.8. What you said, you're not necessarily wrong, but then not totally right. Why? Let's look at this. Consider a number line, for instance. If I have a number line here, where this is 0, okay? I have this as what there? 1, 2. For now, let's consider even numbers. I'm having 2, 4, 6, 8, 10. Besides, what do I have here? Minus 2, minus 4, minus 6. Question, minus 2, is it even? It's even. It's even. In essence, if you say this is a collection of even numbers less than 10, what you're saying is now 8, 6, 4, 2. But then there's still a negative 2, negative 4. So it's not totally correct. So how do you say it? Huh? Positive even numbers. Less than what? Right. Yes. So that's actually correct now. Now it's correct. Now it's correct. Because you also have negative even numbers, still less than 10. Yes. So I will define this as what there? A set of positive even numbers less than what there? 10. Now that's one. Question 2. If I define this as a set of positive even numbers less than or equal to 8, is that correct? Listen, please. The first one is saying less than 10. Less than 10. The second one is less than or equal to 8. Would this be correct? What's the difference? If I say less than 10, it means all the numbers before 10. If I say less than or equal to, it means all the number before 8 and 8 itself. So if I do positive number, that's from this, less than 10 becomes 2, 4, 6, 8. That's correct. If I do less than 8, it becomes 2, 4, 6, and equal to. So I'll add 8 again. So it's correct. In essence, I will define this as, now look at this, please. Now, it's one thing to know how to say it. That's one. It's another thing to know how to write it. The exam you're going for is a written exam. So it's one thing to know something, it's another way to know how to write it down. So how do you write this down? We'll call the set A. So we'll say this is equal to A, where A is equal to X, such that this is read such that, please, in set, this is read such that, right? So you can add it there. This is called such that. Such that. So say A is equal to X, fiam, how do you call this? Slash. What do you call it? Such that X is a positive even number, even, please let me take this up, please. Just remember I said this is equal, this is called such that. It's a positive even number. It's a positive even number. Let me go to the first one, less than 10. Or you could use mathematical notation, just do less than 10. This is the correct. All right, so you have this. All right, so this is what is called set builders. So this is read, a set A is equal to X such that X is a positive even number less than 10. That's all. This is called set builders notation. What did I do? I properly described the set. That's why it's called set builders. Number 2, by listing. By listing. The first one there is set builders. The second one there is by listing. Let's look at by listing, please. Let's look at by listing. By listing, please. Take down, please. This involves writing out all the elements in the set. This involves writing out all the elements in the set. This involves writing out all the elements in the set by listing. This involves writing out all the elements in the set. Writing out all the elements in the set involves writing out all the elements in the set. Some of you, assuming I said define listing, you now say this involves listing out all the elements in the set. Hey, when you're defining a term, you don't use that same term, right? The listing here. So what is set notation by listing? It simply means listing out all the elements. No, get a synonym. Listing is here, so use another word. So instead of saying listing, I use what there? Writing out. That's how you define things. All right, this involves listing out all the elements in the set. So for this man here, look up please. For this man here, I would list out the elements here. For this one here, it becomes, they said, X is a positive even number. Positive even number, 2, 4, 6. They said less than 10. That becomes what there? 8. I'll stop here. That's your answer. So these two are the same thing, but different form. The first one, I was trying to describe it, is called by listing. The second one, I was trying to just list out the elements. I don't have to stress you. So it's possible that in exam, they'll give you this and ask you to list out the elements. It's possible. Or they could give you this one here and ask you to do what there, describe it. Before you conclude, some of you just rush and go and don't just rush. Think about it first. Don't just rush. Let me test you a bit. Or before then, before I forget this, let me test you a bit. But before then, let me give you something. Note something. Note two things. Note two things. Note two things. Number one. Note two things. Then number one, the elements of a set. The elements of a set. Number one, the elements of a set are encased in a curly bracket. Number one. The elements of a set are encased in a curly. By curly, I mean this. Please. This is an issue for most persons. If I check through your notes now, you didn't write it correctly. Person now come. Now do. Please, not that difficult. It's not that difficult. Look at this. Right? Just curve it. Curve it, that's all. Please. Curve it, that's all, please. Not that difficult. In essence, if I'm doing set, for this man here, if I write A being equal to round bracket 2, 4, 6, 8, this is not set. Please, in set, we don't use round bracket. I've seen where people just omit and just use round. After all, it's the same thing. It's not the same thing. If you use round bracket, that's not set. If you use square bracket by saying A is equal to this, you have 2, 4, 6, 8. Please, this is not set. Please, for it to be set, it must be what there? A curly bracket. Then there are those set of persons that do this. They will now do this. Okay, not even this one, self. They will do it this way and then put a gap at the center. What's this? Some of you are guilty of this. And then at this point, now do this. I do this in here. Something like this. Some of you, you know yourself. You're guilty of this thing. You just did this in your notes. Please avoid this thing. So it's not a set. It's not that difficult. One is pointing to the left. Yeah. One to the right, please. It's not that difficult, please. I have to stress this thing. I have to stress this thing so you get it. Some people just overlook it. It's the same thing. It's not the same thing. It's not the same thing. So note number one, I said the elements of a set are encased in a curly bracket. Note number two, the elements in a set. Note number two, the elements in a set are separated using a comma. Very important. Note number two, the elements in a set are separated using a comma. The elements in a set are separated using a comma. That's it, please. Note number two. The elements in a set are separated using a comma. What's the difference? Simple. In my mind, I want to tell you that I have a set Z being equal to, let's say, 3 elements, 2, 7, 9. I have this. In my mind, I want to tell you that a set of 3 elements, 2, 7, 9. But then I forgot and I wrote Z is equal to this. And I write 2, 7, 9. What's the difference? Simple. In this case here, I have 3 elements. 2, 7, 9. In this case, I have what there? 1 element. 279. Please get these things. Get these things. I've seen people make just silly mistakes like this and it costs them. So please use a comma there. This is a set of 1 element, 279. This is a set of 3 elements. 279. Again, 2. As weird as this might sound, I've seen somebody said this is a set of an element z equal to, see me now, equal to 2, 7, and 9. Please, and from where? And from where? Please. And is not part of it, please. 2, 7, 9. That's it. There's no and. All right. Are we good? Let's proceed. Let me test something. Test something. What do I give you now? All right. Take down. Let's try something. Let's try something, please. Take down. I'll give you this. Here's a task. Here's a task. I'll give you in set builders. You list it. In some examples, I will list it. You give me in set builders. That's it. I'll give you in set builders. You list it. Or I will list it and you give me in set builders. Please, let's go. Sample problem. Sample problem. Let's try this. Sample problem number 1. Let's say we have a set of terms P such that P is equal to X, such that X is the number of bones in the human body. We have this. Okay. Number 2, we have a set M where M is equal to okay, 20, 30, 40. I'll stop here. All right, let's play with these two and then we'll move on. Play with these two and then we'll move on. See if you can figure these two out. I gave you this one in set builders. Give me in listed form. I gave you this in listed form. Give me in set builders. I'm giving you just 3 minutes. Your time starts now. 3 minutes, please. Give you 3 minutes. Your time starts now. For my engineering guys, they don't do biology. You've forgotten the first one. I sympathize with you. I know. I did engineering, so I know. But the last time I did this was in SS1. So I understand. Understand. So you can just fade that one peacefully. Yeah? Understand. Now try number 2. Let's see. All right, you have less than 120 seconds. You have less than 120 seconds. What can you come up with? You have less than 120 seconds. What can you come up with? I'll be back in a jiffy. I'll be back in a jiffy. In a jiffy. Is it done? Is this writing? 1 hour. Just check if it's writing. All right, time up, time up, time up, time up. So look up, look up, look up, look up. Look up, please. If you're done, raise your hand. You're done, raise your hand. You're sure your answer is correct, raise your hand. All right. So listen. At this point in your learning career, note that intelligence is just half of what you need to pass exams. Aside intelligence, you must skill yourself up with certain things. Things like what? Being fast, being able to answer questions fast. Very important, right? Some of your guys, your senior colleagues now, are writing the NLNG exam. I went to check up with them. Some of you, if you see my first post, I said this class was supposed to start by 10 a.m. But some guys now chatted me. They said they had scholarship exam with NLNG today. So I had to move your class to 11 so I can help them with the setup. Right? They've already started since. The exam is 1 hour. So in 1 hour, you have to answer about 60 questions. That means one question per minute. So every question is 60 seconds, including comprehension. You read comprehension, understand it, and answer the question correctly in 60 seconds. So at this point, now it's not about if you're very smart. Are you fast enough? So in writing exams at this level, it's about speed and accuracy. Speed and accuracy. Let's look at this. For the first one, please, that shouldn't be hard for the college students. We said P is equal to X, such that X is simply the number of bones in the human body. How many? So 6. Simple. So 6. Any commas? No. That's all. So P is equal to 206. That's all. So this is by set builders. This is by listing. Number 2, M is equal to X. All right. What did you get? What did you write there? Yes, tell us. Yes. Okay. Who else wants to help us? Yes. What do you say? Not X such that M is a set of X such that X is, yeah, it's gone. Less than or equal to 40, okay? If you say less than or equal to 40, there's a plus 10, which is not here. Less than 40. That's not it. Yes, Chief. Let's say Chief. Let's say you. Ranging from 20 to 40, you have 21, 22, 23. Yes, let's say Chief. Emphasis on the term multiples of 10. That's the term to use. When you say multiples of 10, you think about what there? 10, 20, 30, 40, 50. That's what to use. Multiples of 10. That's it. All right. Yeah? Okay. Is that correct? Multiples of 10 becomes positive, actually. Positive, right? Okay, fine. So I'm taking multiples of 10 involves 10, 20, 30, 40, 50. What I have here are multiples of 10 greater than 10. Yeah? 20 is greater than 10. Greater than 10, but what there? Less than what there? 50. That's it. So how do you write this? X, such that X is what there? Now look at this, look at this. Greater than 10, less than 50. How do you write that? Do you remember how you write that in mathematics? Remember how you write this in mathematics? Now look at this. Look at this now. Let me bring you back to SS1 math. Look up, please. Look up, please. Look up. If X is greater than 10, look up, please. We said X should be greater than 10. That's true. Please, if X is greater than 10, that means 10 is what there? Less than what? X. True? That's the first thing there. Number 2, X is less than 50. It becomes less than 50. This is how you represent this. If you can go back to this one mass, this is the way you do it. In essence, you don't say, look, let me give you the idea. You don't say, why it's not wrong anyways, but you don't say multiple of 10 greater than 50 but less than 10. Hey, you have to deal with 10 first before you come to 50. So you're now saying multiple of 10 less than 50 but greater than 10. You're going back and forth. So if I'm doing this, I should start from the small one to the big one. So in my pronunciation or in my write-up, I'll start with 10 first before 50. You're not wrong anyways. You're not wrong. But I'm trying to show you how you do this. And in the representation, you used to, did you remember this stuff here for secondary school? Yes. So learn how to play with less than or equal to. So if you want to write now and say where x is a multiple of 10 greater than where x is or where x are multiples of 10 greater than 10 but less than 50. That's correct. That's correct. Okay, let me just do that. X are multiples of 10 greater than 10 greater than 10 but less than 50. This is correct. That's okay. But then the best way is to say that m is equal to x such that 10 is less than x. X are multiples of 10 and 10 less than x less than 50. This is a more mathematical approach. So if you're okay with this one, that's no problem. You can use this. But then this one is much more preferable. And that's just by the way. Let's proceed. That's just by the way. Let's proceed. All right, so you have this. Keynotes for sets, I'm using curly bracket. Curly bracket, that's number one. Number two, I separate the elements in a set using a comma. Right. All right, if you're done, we don't have so much time to practice other examples. I'll drop questions so you can practice. For now, let's proceed so we can meet up target for today. Next up, please, subheading. We've looked at set definition, set notation. Subheading 3, types of sets. Subheading 3, types of sets. Subheading 3, types of sets. Types of sets. The first one there is Singleton. Types of sets, please. The first one there is called a singleton. As the word says, single, one. Take down, please. Oh, before then, let's look at something called an empty set. Before then, please. Let's look at empty or null set. Let's start with some, please. That's empty. Empty, also called a null set. Let's start with this, please. Please. Before then, please. Let's look at an empty or null set. As the word says, empty. When something is empty, what happens to it there? It contains what there? Nothing. Take down, please. An empty set is a set that contains no elements. Please. An empty set is a set that contains no elements. An empty set is a set that contains no elements. Full stop. It is represented by this or this. This man is called phi. Right. Phi is a Greek symbol. So an empty set is represented by this or this. An empty set is represented by this or this. Example. Let's say I have what? Y being a set of X. Let's say we have Y being a set of X such that X is a state in Nigeria that begins with X or with letter X. Please, question: is there any state in Nigeria start with X? It becomes what there? The empty set. For example, in this case, Y. I say Y is equal to 5, or you say Y is equal to this. So this is an example of an empty set. So yes, empty sets exist. A second example of an empty set, you can say a set B is equal to X such that X is equal to number of presidents with 5 heads. Please, any president that has 5 heads? Empty set. So I'm giving you examples. After empty set, the second thing you look at is called Singleton. Let's look at something called Singleton. Let's look at Singleton. We've looked at empty set. Let's look at Singleton. Empty set has no elements. A singleton, as the term says, single, one. Take that, please. A singleton is a type of set that has just one element. A singleton is a type of set that has just one element. We call it element. The element or element. My Hebrew brothers will say element. Element, element. All right. A set of what? A kind of set that has what there? Just one element. Example, Q is equal to, let's say, A. What I have here is a singleton. Singleton. How do you describe this? This is a listed form. Give me a set builder, what will it be? In set builders, I'll say Q is equal to X such that please, okay, first lowercase. First lowercase. Very important. Right? Please, you don't assume that this and this are the same thing. No. First things first, observation. This is a lowercase. What does I say small letter? Small letter. Small letter. I beg, this one is a big letter. Let me know. Big letter. Please, uppercase, lowercase, small letter. All right. So X is a lowercase. That's one. What else? The first letter, the first lowercase letter, right? Of the what? Not of the alphabet, though, of the English alphabet. There are different kinds of alphabets. There's English alphabet, there's Greek alphabet. In your English, you have A, B, C, D. Capital A, small a, capital B, small b, capital C, small d, yada, 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 X, Y, Z. This is English alphabet. In Greek, when you have A, B, C, in Greek, you have alpha, beta, gamma. So A in English is alpha in Greek. B in English is beta in Greek. C in English is gamma in Greek. M in English is mu, what you call micro, 10 to the power minus 6. Yeah? N in English is nu. You're not using this. This is actually what is called viscosity. This is for viscosity. So you have Mn. Then Z in English is omega in Greek. This is where we get the concept of God, of them saying that God is alpha and omega. It means it's the first, the last, the beginning, and the end. Before you now get spiritual tomorrow and say alpha and omega, meaning that he's the provider. Which provider? Provider. All right, let's proceed. Let's proceed, please. All right, so we say x is equal to x is the first lowercase letter of the English alphabet. Now that's a good description. That's it. All right, that's a singleton. Let's proceed. So when I have just one element in a set, that's called a singleton. No big deal. If there's no element, it's an empty set. Please note, please note that this see empty set. Empty set is this. This one here, is it an empty set? Wait now, before you rush an answer, look at it very well. We said empty set is just always call me, right? What you have here is not an empty set. What you have here is a singleton of the element phi. Please, take down, please. Note, this is not an empty set. Take down, please. This is not an empty set. Note that this one here is not an empty set, but a singleton of the element phi. But a singleton of the element this one is called phi. But a singleton of the element phi. By the way, let me just stress this. Depending on your author, some authors will write phi as 0, they'll cross it straight. Some will write phi as 0, they'll slant it. Whether this one or this one, they are the same thing. They're both phi. Then you now have theta. Funny enough, phi and theta are also alphabets of the Greek letters. So almost all those symbols you use in science are actually what they're Greek alphabets. Alpha, beta, gamma, theta, phi. They are all Greek alphabets. Why are we using Greek alphabet? Simple. Because the Greeks were literally one of the first persons that pioneered science. So they use their alphabet to do what they represent certain things. And that's what we are using up to this Elon Musk's age. Right? All right, so we have this. Number 3, type system number 3, finite. What do you call this? Finite or finite? Okay. And non-finite. Infinity. Why is it now not finite? Infinity. Infinity. Finite. No, finite. Finite infinity. Okay, finite and non-finite sets. A finite set is a set that has a finite set is a set that has or let's rephrase that. A finite set is a set whose number of elements can be counted. Let's use that way, please. A finite set is a set whose number of elements can be counted. A finite set is a set whose number of elements can be counted. The set whose number of elements can be counted. Example, you can say a set. Let me use something like this. Example, a set of f being equal to x, such that x are the number of states in Nigeria. This man is finite because it can be counted. Can count, so it's finite. You can say f is equal to x such that x is equal to the number of teeth in a human's mouth. It's finite, it can be counted. What about infinite set? Non-finite set, please. What about non-finite set, please? Let's look at non-finite. So basically, by logical extension, non-finite sets are simply a set whose number of elements cannot be counted. How is that possible? Okay. What's a bag of rice? So if I give a bag of rice, you know if you count it. All right, non-finite set. Let me call it. So I said it's a set whose number of elements cannot be counted. Cannot be counted. Cannot be counted. Let's use something. Now, by the way, don't confuse something though. For the fact that since we started, I've been using x does not mean it must always be x. It's just that globally, generally, they use x. I could still switch up things. What do I mean? I could say an element x such that x is equal to m such that, so it's still possible. In essence, x must not always be here. But if you check most texts, most authors, generally we use x in the brackets. But then bear in mind that we could still switch this up and it's still the same thing, nothing spoils. Give me an example of a non-finite set. In what? Number of stars where some of them can be counted. If you use a particular location, possibly there could be a counting. What do we say? Yeah. Number of hair. You can't count number of hair. Are you sure? M is the number of sand on a seashore. On a seashore. All right, this works. Number of head, human head, can it be counted? Like you, once you want to count it, we're not using manual counting, no. That I want to believe the assistance where you just put your head there and you scan all the hair pores and tell you, tech has gone foul. It's not as if you maybe use your hands. Like, no. There could be a machine where you just put your head and you count the number of hair pores. It just tells you. It's possible. Possible. So you go check the research. So this works for me. Number 4, subset. Number 4, subset and superset. Number 4, subset and superset. Number 4, subset and superset. Number 4, subset and superset, please. Excuse me. Yes. His own. Is it done? Until it went off. Time to come. Does he have a charger there? Why not tell me now? Subset and superset, please. Take down, please. Two sets A and B. Given two sets A and B. Given two sets A and B, such that given two sets A and B, such that all the elements in B are also contained in A. Given two sets A and B on the board, such that all the elements in B are also contained in A. Given two sets A and B, such that all the elements in B are also contained in A, comma, then B is said to be the subset of A. Then B is said to be. Okay, that still works. Then B is said to be, then B is said to C. That still works. then B is said to be the subset of A, written as B subset is, look at this please, and equal to, and then this. This is how you write something, please. This means B is a subset of A. It's not a C. Some people write C. It's not C. All right. I see people writing like this: B, C, A. Huh? Q, then B is a subset of A, and A is the superset of B, and A is the superset of B, written as this, and equal to, then you call this, then you put B, and A is the superset of B, written as A, this, B. It's not that deep. Sub is left, super is right. I think that's easy. When it's sub, to the left, go to the left. When it's super, to the right. That's simple. Example, if I have A being equal to something that looks like 1, 3, 5, 7, 9, and B, it's equal to, let's say I have 3, 5, 9. Okay? B is called a subset of A. Yes. Why? Because if I look at this very well, all the elements in B are also in A. It's called a subset. A becomes the superset of B. No big deal. That's all. That's all. Let's do this. Let's do this. If I say X, it's equal to 1, 2, 4, 7, 9, 11. This X. And I say Y is equal to, let's say, 1, 3, 7, 9, 11. All right. Which is the superset? Which is a subset? Superset is what? Superset is what? X. Good. Subset is what? Y. Huh? Superset is what? X. Then Y is what? Y is subset. Okay, Y is superset. Y. Y is superset. Y. Y is subset. Y. When you read definitions, listen carefully. For something to qualify as a subset, all the elements, without an exception, should be what there in the other one. Y has 3. Is there any 3 here? So Y is a subset. This man has 2. Is there any 2 here? So there's no subset, there's no superset. That's it. That's the answer. So please be careful. So X is not a subset of Y, and it's neither a superset. They are not even related. So in essence, we can say X is, look at this now, look at this, watch this. This is subset. We'll do this. This is red. X is not a subset of what there? Y. That's it. Be careful with your definitions, please. All right, let's proceed. Let's proceed. All right, let's proceed. Okay. Number what now? 4. Number 5. Let's look at something called the cardinality of set. Cardinality of a set. Let's look at. Please, yes. Please feel free to ask questions. If you have, just raise your hand and ask. Yes, Chief, let's hear you. And what? What's a subset and a superset? Simple. A is a superset, subset. For something to be a subset, it has to have all of the elements in the subset must be contained in the superset. If you look at this, we said B is a subset of A. Why? B has 3 elements, 3, 5, and 9. What's your observation? The same 3, 5, and 9 are still in A. So B becomes a subset. What about the superset? For a superset, I have 1, 3, 5, 7, 9. On a normal context, a superset usually have more elements than the subset. That's one difference. The superset has 1, 2, 3, 4, 5. This one has what there? 1, 2, 3. That's one difference. For the universal set, we'll discuss that when we come to that point. We're not there yet. I'll discuss when we come there, you see the difference. Yes, let's hear it. This means X on the normal. On the normal, if I have this would mean X is a subset of Y. If I now cancel it, it means it is not. This is red. X is not a subset of what there? Y. We good? Yes. Mm-hmm. Yep, it still works. X is not a subset of Y. Y is not a subset of X. X is not a superset. Yes, it's the same thing. Yes, so it's the same. So even if you choose to say it can be written as Y is not a subset of X. Yeah, it's the same thing. Anyways, yes, this. Cardinality of a set. Please take down, please. Given a set P, please capital letter P. Given a set P, please capital letter P. Given a set P, comma, the cardinality of the set is written as NP. The cardinality of the set is written as NP. The cardinality of the set is written as NP. It simply tells the number of elements in that set. It simply tells the number of elements in that set. It simply tells the number of elements in that set. Example problem. If P is equal to 1, 3, 5, 7, Q is equal to this, R is equal to 1, 7, 11. So look up, look at this, 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 look up, look up, look up. All right, if P is 1, 3, 5, 7, then N of P simply means cardinality of P, and that means how many elements do I have in P? Please check how many do I have there? 4. 1, 3, 5, 7. N of P is 4. That's all. N of Q is how many? How many? Zero. Why? No elements. An empty set or a null set. Okay? N of R. How many? 3. 1, 7, 11. All right, so that's it basically. So when we say cardinality, it's just simply how many elements we have there. So that's how you do it. So if it asks you, evaluate the following, N of arrow, you know what that means? It's called cardinality. It simply means how many elements are there. That's all. Sometimes they'll give you statements, true or false. You now say the cardinality of an empty set is 0. True or false? True or false? True. The cardinality of an empty set is 0. What does it mean? An empty set has what there? No elements. All right, let's move on. Number 6, pair set. Number 6, pair set. Let's move on. Number 6, pair set. Let's do pair set. Before we do pair set, let me stress something. Before we do pair set, let me stress something I should have said here. Note that when it comes to the concept of subsets and supersets, every set is a subset of itself. You can notice that. Every set is a subset of itself. 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 Very important, please. Look at A and B. They're the same thing. Can we say B is a subset of A? Huh? They're exactly the same thing. Can we say B is a subset of A? Yes, we can. Why? Because every set is a subset of itself. We should note that. All right. With this concept, let's deal with something called pair set. Please take that, please. Pair set. Question, please. Yeah. It's just B is a subset of B. No big deal. B is a subset of itself. Same thing. If and only if all the elements are the same thing. Let's do pair set, please. Take that, please. Yes, please. Yes. Let's do a superset. Every set is a superset of itself. Yes. Every set is a subset of itself. Yes. And every set is a superset of itself. Yes. But we don't work with the superset. We work with the subset. But yes, it is. By logical extension, it is. Pair set. Take that, please. Given a set Z, we have that on the board. Given a set Z, the pair set of Z is represented by PZ. Mind you, please mind you. Please look up. If I'm doing pair set, the P there is a small letter P, PZ. It is not PZ. This is wrong. This is right. Please get this right. The P there is a small letter P. Please. Small letter, not capital. All right. So I said, given a set Z, the path of Z is gotten by PZ. It simply tells, it simply gives, okay? It simply gives or tells the number of subsets. It simply gives or tells the number of subsets. It simply gives or tells the number of subsets that can be derived. It simply gives or tells the number of subsets that can be derived from any set. It simply gives or tells the number of subsets that can be derived from any set. Full stop. It is got by the formula Pz is equal to 2 to power n. It is got by the formula Pz equal to 2 to power n, where n is equal to number of elements in the set, where n is equal to number of elements in the set, aka cardinality, where n is equal to number of elements in the set, aka cardinality. In your test or exam, they'll give you a set and say evaluate PZ or P of whatever abbreviation is there. Or they'll say, how many subsets can you find here? How do you know? Through the pair set. A pair set tells you the number of subsets that can be found in any given set. We'll take some examples and I'll explain this. Look up, please. Let's say I have a set. Let's start with Z. Okay, it set Z being equal to this. Right? Sample problem. Evaluate the pair set of the following. Example, evaluate the pair set of the following. Example, evaluate the pair set of the following. We have this. You have this. Let's start with this. You have this equal to, okay, you have this being equal to, okay, you have this being equal to, my gamers, you know what we're doing, right? My gamer, you know what we're doing, right? Yeah. Some females cannot relate. Yeah. I feel your pain. My gamer is what I'm doing. Okay. F5. Let's say you have something that looks like, what do we use here? Let's go back to ABCD. So A, B, C, D, and E. All right. Evaluate pass of the following. So you have example 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. I'll do 1 to 5, you go try out 6. I'll do 1 to 5, you go try out 6 on your own. I want to clean up, please. All right, copy fast, please. I want to clean up, copy fast. All right. Please look up. Z, it's equal to, we have this. All right, please look up. Let's get a pair set for Z. For this, so PZ, it's equal to Please, for this case, please, what's n here? 0. Why 0? No elements. P is equal to 2 to the power n, and that's equal to 2 to the power, what's n there? 0. 2 to the power 0 is equal to what? What law is that? Logarithm. This is partial fraction. What you looking there? This and that. 2 to the power 0 equal to 1. Which law is that? Next is logarithm. Which of them? Which law is this? Huh? 0 law. The law is logarithm. The law is logarithm. The law is indices. Hey, you get your facts right. You get your facts right. What law is this? This is a law in indices. The law is not indices. No, it's a law of indices. It's called the zeroth law of indices. It's not indices. It's called the zeroth, zero with a th. The zeroth law of indices. What does it say? All right. The zeroth law of indices says that anything raised by 0 equal to 1. True or false? False. Capital false. The zeroth law of indices says that anything raised by 0 equal to 1. True or false? False. False. There's an exception to that law. Carry your calculator, punch it. 0 to the power 0, you have math error. Punch it. Punch it. Try it. 0 to the power 0. What you see, there's math error. In essence, the zeroth law of indices says that any number to power 0 is equal to 1 except 0. Please get it right. This is not SS3. Oh. This is A1. This is A1. That's why when a A1 student is talking and an SS3 is talking, difference will be there. Difference will be there. This will be there. Get it right. All right. 1. So look up, look up, look up, look up, look up. This means that this thing here has one subset. Let's list it out. From here, the answer is simply what there? Itself. Listen, please. Listen. 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 Let me tell you a concept to get used to. Get used to not understanding something at the first time. Listen carefully. This is not your secondary school. Get used to not understanding something at the first time. In essence, just watch, look at example 2, example 3, you'll catch it. So listen, I just said this man here has only one subset. And we said the subset is an empty set. How? Relax. Let's try example 2. I will link them up. Just listen. Example 2, we have B is equal to A. Let's get past it here. P of B is equal to 2 to the power n. This is always your formula. In this case, what's n here? 1. I have just one element. That's equal to 2 to the power 1. Please, 2 to the power 1 gives you what there? Please, 2 to the power 1 gives you 2. That means this element here has 2 subsets. When it comes to listing subsets, please listen. When it comes to listing subsets, always start with an empty set. Just hang on. Always start with empty set. So I'll have this one first, and then take them in ones. It becomes A. That's your answer. Hang on. Just hang on. Hang on. Don't write. Just listen. Let's take C. C is equal, the third one, C is equal to A, D. Don't write. Just listen. For this, I'll give it time to write. Just listen. P of C is equal to 2 to the power n. Please, in this case, what's n here? 1, 2, 2. So it becomes what there? 2 to the power what there? 2. That's equal to what there? 4. This man has 4 subsets. List them. The first one is always what there? An empty set. The first one is always an empty set. I will come here, write empty set. After empty set, what next? Take the elements one after the other in ones. Take this in 1. It becomes what there? A. What else there? D. After taking them in ones, take them in twos. If I take them in twos, it becomes what there? AD. If I count how many? 1, 2, 3, 4. 4 subsets. Hang on. Hang on. Let's try one more, then you can copy, please. Let's try one more, then you can copy. D 1 to 3, okay? D is equal to 1, 2, 3. All right. So, and here, you have 3 elements. So it's 3. And 2 to power 3. Please, 2 to power 3 is what? Right? 2 to 4 times 2, 8 is 8. Somebody said 6. Who was that? You didn't have in your mind. I felt in my spirit. Somebody said 6. Who was that? Who was that? Confess now. All right. That's 8. Now, let's do this together, please. Let's get 8 subsets. List them out. What do you start with? Take an empty set. That's 1. Please, though, hold on. Let me rephrase this. Can I write this as being 5? Is that correct? Correct. Those that came late, we talked about this earlier. Said 5 means what there? Empty set. The same thing. I've gotten 5. Please, after empty, what next? Take them in ones, one by one. So please give me this one by one. What's first you have there? 1. Okay, let's go again. 2. Okay. 3. I've taken them in ones. Now take them in twos. What will it be now? 1 comma, right? 2. What else? Suppose it's 2, 3. 1, 2, 1, 3. Okay? This now becomes 1, 3. I'm taking them in twos. So hold on. Empty set 7, 8. Correct. Let's try one more. All right. Can I clean this? Anybody here? All right. So copy. I'm waiting. Copy. So please know how we do this, please. Empty set in ones, in twos, in threes, in fours, as the case may be. Please. Please come fast. I am waiting for you. Please copy fast. I am waiting for you. The way you hold your pen is evidence that you cannot write fast. The way you just hold your pen, you can't write fast. Is that you handle pen to slow you? Actually. Anybody see here? Okay. Anybody see here, please? Okay, I'm hearing here, so I'll leave it. Give me E, please. E is equal to what again? Triangle, circle, block, X. Shoot pass, shoot it off, score your goal, short pass. If you're playing what do you call it? WK24, wrestling, my second favorite game there. You know what it means. You're playing GTA, get out of the vehicle. What's the song of GTA? What's the song? You're not gamers. Oh, that's sad. So what do you do at the time? Read book, you don't read book. Play, you don't play. What do you do at the time? Watch movies. Okay. All right, are we done now, please? All right. Let me get this up. All right, all right, all right, all right. Let's get this man done. Let's get this man done. Just copy. I'm waiting for you. Are we good? Let's start this, please. All right, let's get this done. First is first. P of what? What's n here? N is 4. Let's get P of E. P of E equal to 2 to the power n, and that's equal to 2 to the power n is what there? 4. That gives you what there? 2 times 2, 4 times 2, 8 times 2, 16. I'm expecting 16 subsets. All right, let's get the subsets together, please. First things first, I'm starting with what there? Your empty set first. Your empty set first. Please give me empty set. I am choosing to use 5. That's 1. Take them in ones. In ones, what do you have there? Triangle first. Circle. Square. And then X. I am done taking them in ones. Take them in twos. Now hang on. Start with this. So it becomes what there? Triangle, comma, circle. Okay? Okay. Triangle, square. Okay? Right? Triangle, X. I'm done with this one, Abby. Now come to this. What's next here? Hang on. That's circle block. We call it block in gaming. Square. No problems. What next again? Please look at this. This, triangle, this, then this, and then this. When you're done, dump this man. This becomes starting point. So this, circle block. Next up, this, circle X becomes circle X. So I've used this for this and this, this and this. Dump this man. Come to this. What's the last one there? Right. Block X. I'm done with the twos, right? Yes, I'm done with twos. Now take them in threes. Taking them in threes, I have to go back to the what do you call it? Beginning, right? Beginning. All right, to the beginning, please. All right, so back to this man here. Now take it in threes. Now watch this. Watch this. In threes, starting from this becomes 1, 2, 3. 1, 2, 3. Triangle, circle, block. Triangle, circle, block. That's 1. All right, so triangle, block X, that becomes triangle, block X. Can you find any other threes? Or is that all? Circle, block. Circle. We should have done that one, right? We missed it. So let me add it there. Triangle, circle, X. Please, check, please. Triangle, circle, block. I've done that. Triangle, circle, X. I've done that. What's next in there? Circle, block, X. Okay. Let's see. Circle, block, X. Is there another three you can find? Is that all? Now take them in 4. So it becomes what there? Triangle, circle, block, X. All right, that's like everything. Let's see. 16. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Correct. That's it. So it can be actually confusing at the beginning, but just practice it, okay? Take them in ones, zero first, empty, then in ones, in twos, in threes, and then in fours. Just try, you get it. So that's like the concept. The next one, I'm coming. The next one now will be for F. I'm coming, please. The next one here will be for F. The next one will be for F. And you say F is equal to what there? What's F? 1, is it A, B, C, D? A, B, C, D, E. What's N here? 5. P of F is equal to 2 to the power N, and that's 2 to the power 5. That's what there? 32. So you go find this. I'm expecting 32 subsets. Many people make mistake here, but you go try it. So when you're done, count it. If it's not up to 32, something is wrong. So you're missing one. You go try it. Your question, please. It's not compulsory. Don't ask. You could ask. Know it. So it's not compulsory. If they ask you how many subsets are in this, just write there 8, 16. Just write 32. But in some questions, you say how many and list them. If you now say list them, you now list. If you don't say you should list them, just write 16 and go your way. That's it. All right, so we have this, please. We have this, please. Let me chip on. It's not a popular concept. We've been designing. The first one was listen. We are at number what now? Last set was number what? 6. Number 7. This one is not that popular, but then just in case. Just in case. One is not. We look at this. We look at basic set operations. Then we'll go on break. We'll come back. We'll look at Venn diagram. We'll try to do past questions, and that's good for the day. Let's consider the concept of equal and equivalent sets. Let's consider the concept of equal and equivalent sets. Let's consider the concept of equal and equivalent sets. Two sets are said to, two or more sets are said to be equal. If you're done, two or more sets are said to be equal if they contain the same elements. Two or more sets are said to be equal if they contain the same elements, irrespective of the positions. Two or more sets are said to be equal if they contain the same elements, irrespective of their position. Should be there. Irrespective of their position. Two or more sets are said to be equal if they contain the same elements, irrespective of their position. Example, if A is equal to A is equal to 1, 2, 3, 4, and B is equal to 2, 1, 4, 3. Are A and B equal sets? Yes. Yes. They contain the same elements 1, 2, 3, and 4, although not properly arranged, but then same elements. So we can say A is equal to B. So we have this. So we can say A is equal to B. So we have this. This for equal sets. Let's look at equivalent sets, please. This is for equal sets. Let's look at equivalent sets. If you want to say is not equal to, you just slash this. Right? You want to say not equal to, just slash this. That's all. So I'm saying this. If I should add, let's say, for this man here, if I add 3, this, and add 5 here, in this case, A and B are not equal. Not equal. So I can write A is not equal to B. That's it. Why? They don't contain the same elements. All right, one line space paragraph. One line space paragraph. Two sets are said to be equivalent. One line space paragraph. Two sets are said to be equivalent. Two sets are said to be equivalent if they contain the same number of elements. Two sets are said to be equivalent if they contain the same number of elements. If they contain the same number of elements, not necessarily the same elements. Two sets are said to be equivalent if they contain the same number of elements, not necessarily the same elements. What do I mean? A is equal to 1, 2, 3, 4. B is equal to A, B, C, D. Please check. Do they contain the same elements? No. Do they contain the same number of elements? Yes. Each how many? 4, 4. In essence, we're saying two elements are said to be equivalent if their cardinality is the same. We said cardinality tells the number of what there? Elements in a set. We can say, I think in writing, that should be A. Equivalent, I think it's like a 3/B. That's the difference. Equal to is 2, right? This 2. Equivalent is like 3. That's the difference. I have this. So this means A is equivalent to B. Or I don't know if they use approximately, but I don't think it's. I think it's more of this one here, more of this one than this. It shouldn't be approximately. It should be this one instead. But then you can check if this one also works. But it should be this one here. Let me show you how a typical test exam question could look like. They would say, given that A is equal to this, B equal to this, show that they are both equivalent. Show that. Now I'm going to start writing English for them. Show that. How do you show that? First things first, I know that they're equivalent because they have the same number of elements for each. So how do I show it in mathematical form? Very simple. You come here and say, from this, note that n of A. What does n mean? Cardinality, number of elements, is equal to 4. And what again there? N of B is equal to what there? 4. Now say, since n of A is equal to n of B, hence the sets are equivalent. Size done, please. since n of A is equal, this is like the key concepts there, right? That's the key concept. Since n of A is equal to n of B, equivalent set. All right, one last thing. Look at one last concept. Look at this is how many? 7. Let's do 8. Let's look at a second kind of concept. Um, okay, let's stop. Let's stop here. Let's look at basic set operations. I think let's do that one. That's like last thing before we go on break. Come back, do Venn diagram, call it a day. Basic set operations, please. What's the time there? Oh, almost 1 p.m. Basic set operations. Look at basic set operation. Okay, operations. Basic set operations. Anybody here want to clean up? Anybody here? Anybody here? No. Before we look at basic set operations, there's one thing we have to consider. Before we look at basic set operations, there's something we have to consider called the universal set. Before we look at basic set operation, there's something we have to consider called the universal element, usually with a capital U. Take down, please. A universal set is a set of all elements. A universal set is a set of all elements. Universal set is a set of all elements. That's a basic definition. There's still a bit of 1 or 2 restrictions, but we can manage that. Universal set is a set of all elements. It is represented by a U, capital U. It is represented by a capital U. It is represented as or by a capital U. Next one, please. Complement set. Complement of a set. The complement of a set gives the elements that are the complement of a set gives the elements that are the complement of a set gives the elements that are in the universal set. The complement of a set gives the number of elements or gives the elements that are in the universal set but not in that set. The complement of a set gives the elements that are in the universal set but not in that set. But not in that set. But not in that set. Given a set, full stop, then proceed. Given a set A, full stop, then proceed. Given a set A, that's this. Given a set A, that's this. The complement of A is written as a to power 1 is read a prime or a to power c, depending on your author. Some authors use a to power 1 that is read a prime or a to power c, and it works. All right. Let's do this. Let's do this. Let's do this. Let's say u is equal to x such that x, all positive integers less than 11. Okay. A is equal to x. X is all even numbers and x less than equal to all positive even numbers, x less than or equal to 10. Find u, a, and a prime. All right, let's play with this. Given u as whatever thing you have there, a as whatever thing you have there, you have to find u, find a, and find a prime. All right. The numbers here could also be integers, please. We're using integers here, please, just for context sake. Let's get to you, please. Those of you that came late, we discussed this thing here. Builder's notation. Set builder simply describes the elements in that set. We said U is always universal set. Say U is equal to X, such that X are all positive integers. What's an integer? Huh? What's an integer? An integer is a whole number, that's all. When we say integer, it means a whole number. 2 is an integer. Minus 5 is an integer. 2 is a positive integer. Minus 5 is a negative whole number, negative integer. Minus 2.3 is not an integer. Why? Decimal. Decimal. So when we say integer, we mean whole numbers. If I say positive integer, I mean what there? Positive whole numbers. Please, I said, so you will give me all positive whole numbers less than 11. What do you have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Will I add 11? They said less than 11. If I had said less than or equal to, then you add 11. There's no equal to, so I'll stop there. So I have this. Let's get A. They said A is what there? All positive even numbers. Now what's there? Excuse me, please. Wait, you know, please what? Uh-huh. Why don't you call me since? Who's there? Who's around there? Who's around? Is he busy? Because of network. So what should I do now? All right. Let's get A. We said A is what there? X. Such that what there? X is all positive even numbers. Okay. Please. Positive even numbers less than or equal to 10. Even. What do you have there? 2, 4, 6, 8. Do I add 10? Why? 10. A prime. We said A prime is called the complement of A. What does A prime signify? A prime signifies all the elements that are what there? That are in the universal set, but not in A. Please check. What do I have here that's not here? What do I have there? 1, 3, 5, 7, 9. I need somebody to start 11. I just I was waiting. I need somebody to start 11. There's no 11 here. So you stop there. That's it. How would you describe A prime in set builders? What would you say? Odd numbers. That's it. Yeah. They are all what there? Positive odd numbers. Less than 10 or less than or equal to 9. If you're there in class, you know what I mean. All right, so basically that's it. So that's what this might mean. All right, so a to the power 1 or a to the power c, same thing. Basically, that's the concept. Number 3, difference of sets. Difference of sets. Difference of sets. Difference of sets. Given two sets A and B, 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 the difference between the sets can be written as A minus B. When we say difference, we mean what there? Subtraction. The difference between the sets can be written as A minus B. The difference between the sets can be written as A minus B. Which tells the elements in A that are not in B. A minus B, which tells the elements in A that are not in B. Which tells the elements in A that are not in B. Which tells the elements in A that are not in B. Which tells the elements in A that are not in B. Or B minus A, or B minus A, or B minus A, which tells the elements in B that are not in A, or B minus A, which tells the elements in B that are not in A. Or B minus A, which tells the elements that are in B but not in A. Sample problem. Sample problem. Given that A is equal to 1, 2, 3, and B is equal to 1, 5, 4. Sample problem. Given that A is equal to 1, 3, and B is equal to 1, 5, 4. Sample problem. Given that A is that, B is that. Let's do A minus B. What's A minus B? A minus C. Listen. When we say one set minus the other, it simply means the elements in this one here, the first one, not in B. Look at A and B. A has 1, 2, 3. B has 1, 5, 4. Which element do you have? Which element or elements do you have in A that you don't have in B? 2 and 3. It becomes 2, 3. Okay? What's B minus A? What do you have there? 5 and 4. So I believe that's easy enough. That's it. So B minus A means those elements in B, not in A. So B has 1, 1, so it's there, so I won't use it. B has 5 and 4. 5 and 4 are not here. So bring it down. That's the concept. That's B minus A. Note. 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 A minus B can still be written as A slash B, and B minus A can be still be written as B slash A. Please note this, please. In the exam, they brought out this one instead. They mean the same thing. When you see A slash B, it simply means A minus B. Those elements in A, not in B. All right, let's go a bit further. Go a bit further. Go a bit further. Union and intersection of sets. Given two sets A and B, given two sets A and B, given two sets A and B, the union of the set is given by A, U, B. My U did not come with. See, I didn't do this. I didn't say A, U, B. No. This is not there. This is not there. It's not there. Don't go and put this tail in quote there. Just shape it like this and that's all. Don't go and start putting the straight line there. Given by A, U, B. It is a combination of all the elements in A and B without repetition. It is a combination of all the elements in A and B without repetition. It is a combination of all the elements in A and B without repetition. Take a paragraph. Their intersection is written as A, this, B. Their intersection is written as A, this, B. Again, I didn't put this in here. I didn't say A and B. This is not there. This thing here is not there. Their intersection is given by this. Which gives the element which gives the element or elements which gives the element or elements that are common to both sets. Which give the element or elements that are common to both sets. Which gives the elements or elements that are common to both sets. Using the same example there, if I have A as being equal to, okay, let me use something else now. Let's say I have 1, 2, 3, 4, and I have B as being equal to 1, 3, 5, 7. I have this. First things first, A and B are equal sets. True or false? A and B are equal sets. True or false? A and B are equivalent sets. True or false? For you to be equal, they must have the same. They are not equal. They are not equal. A has 2 and 4. B does not have 2 and 4. But they are equivalent. True or false? Yeah, they're equivalent. It has 4 elements. 1, 2, 3, 4. This has 4 elements. 1, 2, 3, 4. That's the first note. Next up, what will be their intersection? The intersection is simply A, this, B. I said the intersection tells, okay, I mentioned union first. Let me start with union, please. I said when we talk about union of sets, for union of sets, I am combining all the elements in A and B in quote without repetition. So if there's any element common between them, you don't repeat it. In essence, this becomes I have 1. 1 is common here. You take 1. You don't say 1, 1. No. Next up, 2. There are 2 threes. You don't say 3, 3. Just take what there? One of the 3. What again there? 4. Again? 5 and what there? That's simply union of sets. You're combining all the elements in that set. You're not repeating any one. That's union of sets. Let's take intersection. A intersection B. So we said for intersection, I am simply taking the elements that are what there common to both of them. So look for that element that both of them have, and that's the intersection. What do they have in common? 1, 3 becomes 1. All right. So that's it basically. That's how you do intersection and union of sets. That's it basically. What am I omitting? I think that's what else am I missing? By the way, note that difference is also called relative complement. Please just note it. Relative complement. Note that difference of sets is also called relative complement of sets. That's side note. That's a side note. All right. We'll take just one example, then we'll go on break. Okay? For example, then we'll go on break. Come back from break, we'll discuss Venn diagram in details. When we're done, we'll do past questions, and that's all for the please. So let's just take just one question to buttress everything we've done, and then we'll go on break, please. Sample problem. Sample problem, given that u is equal to x such that x ten less than or equal to x Sample problem. Let's say we have u be equal to x such that x is what? 10, or x is less than or equal to 10 and less than 20. Right. And x are even numbers, and x, okay, are even numbers. Fine. Let me just leave it here. B is equal to x. X are find number 1 u, number 2 a, number 3 b, number 4 c, number 5 p, a, number 6 n, c, number 7 a minus b, number 8 a minus b intersection c, number 9 a minus c prime union b, number 10 a union c intersection b intersection c, number 11 a complement minus b union intersection a. Mister, don't tie yourself. All right, that one. Let me not stress it too much. You want to get the idea, you know how to run with it. So I don't have to stress that much. Okay, let me just complete this. So is PA equal to NB? Aha! I forgot to tell you something. (13) is please, let's look at 13, please. 13 is this is disjoint. That's it. Okay, so just play with these ones. I may not do all. I'll just do some. You get a concept. You go finish it up later. Before then, disjoint set, please. By definition, a disjoint set is simply a set that has no intersection. That's all. A disjoint set is a set that has no intersection. So when sets do not have any elements in common, they are said to be disjoint. So disjoint sets are sets that do not have any elements in common. Please take note, please. Disjoint sets are sets that do not have any elements in common. Please, that's all. So by the time you do the intersection and there is nothing, it's called a disjoint set. That's all. All right, let's run through this. Yes, please. Sorry? No. Yeah, you just say A and B are disjoint. There's no symbolic representation. It doesn't exist. Maybe it exists. You can go check it out, but it doesn't. There's no one there. All right, let's run with this. Number one, let's say this. Find U. So U is equal to, please give me U, please. What will U be? There's an equal to here. So this number is what there? Inclusive. That becomes what there? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right. They said less than 20, there's no equal to. So you don't include 20, there's no equal to. Let's get B, I. Let's get A. A, what do you observe in this case? Observe that it said even numbers. They didn't say integer or everything there. Why? Why did they say less than this? They didn't have to bother. Why? Because all your sets must fall in the universal set. The universal set is actually your boundary. So they don't have to now start stressing and saying even numbers where x is like they don't have to. If you tell you even numbers, those even numbers must fall in between universal sets. That's the concept. So your task here is to pick out even numbers here. So what do you have there? 10, 12, 14, 16, 18. That's all. Who doesn't know what even numbers are? Who doesn't know? No, serious now. Who doesn't know? Feel free. Who doesn't know? Okay, you're not sure. Who doesn't know? Who's not sure? Don't be shy. You say something. Who's not sure? As I was just writing, something told me that there's somebody doesn't know what even numbers are. And when something tells me, I know it's true. Somebody does not know. Who doesn't know what even numbers are? Be serious. Who doesn't? Yeah? You don't. I said, I knew that somebody didn't know. I knew it. Please, even numbers are those numbers that can be divided by 2 without a remainder. Right? They're usually numbers that you can divide with 2 without remainders. Those are even numbers. And whenever I'm teaching, I do not want to believe that everybody is flowing at the same pace. We all have different pace of learning. So I try to, as much as I can, break it down to the faintest and the most minute particles, where even somebody that has a half brain would listen and understand. Because Nigeria, just pray that some of you, Nigeria has not happened to you before. You don't know what life can be. Tell you a short story, then we'll continue. When I was in my third year in school, that was like my year 3 in school, my third year. There's this guy that used to come to my class in my third year. So you come to class and he's actually very old. Like, if you see a very old, you know, very old. You see all the beers and everything. Very old guy. You sit down, see me at the extreme there, just at the back there, and you'll be looking at what I'm doing. You see the frowning in his face, right? And you see the struggle. If somebody's struggling, as a good teacher, you know. You see the struggle. And he comes to me and like, okay, he's trying, like he always comes to class, but he still struggles. So one of those days after class, I come to call him, I'm like, come. So I've been observing that you've been coming to class, you're punctual, you're trying to do your best. But I was that there's a struggle, right? He now told me that yes, it's a struggle. I said, what's the issue? He now told me, he said he left secondary school some years back. He told me the year he left secondary school. The year he left, the year he's finished SS3, I was in JS3 when he left SS3. I was in just 20 year. And now I was now in year 3 and he was in year 1. Like he left SS3 and he was at home. I did SS3, I did JS3, I did SS1, was still at home. I did SS2, was still at home. I did SS3, was still at home. I wrote my first jam, scored 254, didn't get admission. Crazy, right? Yeah. Well, I wasn't bothered now. I wasn't bothered. It was disappointing though, but I wasn't bothered. I still wrote my second jam again. Now he was still at home. I got admission. I did year 1, was still at home. I did matric, was at home. I ate matric rice and did rag day, was at home. So emphasis on those days, right? Yeah. Entered year 2, was still at home. It was now in my year 3. Now count how many years. How would you expect atom definition to be in his head? How? You don't go finish now. So whenever I'm teaching, I don't want to assume that all of you just came from SS3 and then no, those guys are there. So I try to ask the most basic of questions. So please, if you don't understand anything, please call my attention. Please call my attention. All right, back to base. Let's get A from here. We've gotten A. Let's get B, please. I'm on camera. There's I don't see when I'm on camera. I'm being filmed, so don't worry. I'll just see later. Let's get B, please. B are odd numbers. odd numbers in this range. Give me odd numbers. So it's simple. Those numbers that are not even become what? There? Odd. That's like the simplest concept. Becomes what there? 11, 13, 15, 17, 19. All right. I, V, 4. Give me C. We said C are what there? Multiples of 3. 3 timetable. 3, 6, 9. What again there? 12. Something 12. 12. After 12, 15. Okay. After 15, 18. And that's all right. Because after 18, you have what there? 21, which is not here. So I'll stop at 18. These are the multiples of 3. So for multiples of 3, just take your 3 timetable. 3, 6, 9, 12. So start from 12. 12, 15, 18, 21. 21 is not here. Leave it out. So I have this. All right. V said we should find what there? Power set of what there? A. P of A is equal to what there? 2 to power n. B. For A, what's n? N is equal to 5. For A, we have 5 elements. 1, 2, 3, 4, 5. So that means P of A is equal to what there? 2 to power 5. That's equal to what there? 32. That's all. Okay. VI 6 says find n of C. N of C means what there? Cardinality of C. And that simply implies what there? Number of elements in C. Come to C. Count. How many elements do you have there? 1, 2, 3. The answer there is 3. Next up, A minus B. So I'm taking this as VII. A minus B. What's A minus B? It's called the difference of sets. And I said A minus B tells you the elements in A, not in B. Please look at these two. What elements do I have in A, not in B? Okay, all of them. 10 is not here, 12 is not here, 14 is not here. Okay, so that becomes 10, 12, 14, 16, 18. In some questions, they'll say, prove that A minus B is equal to A. In some questions, they'll say, prove that A minus B is equal to A. Don't go and start doing collect like terms. Minus B is equal. Don't go and start doing collect like terms. That's not the idea here. The idea here is just simple. Get the value of A minus B. Look at it here. Observe that A minus B value is the same thing as what there? A. So you now say A minus B equal to 10, 12, 14, 16, 18. Also A equal to 10, 12, 14. So you now say since A minus B is equal to this and A equal to this, then they are equal. That's how you do it. That's the concept. What's next in there? VIII A minus B intersection C. Please, let's be careful with this. A minus B intersection C. Is there any element? I want to say intersection. Please listen. This is where it gets serious. When you're dealing with this, deal with them in brackets. In essence, I am dealing with this one as one set against this one. So I'm taking A minus B. What's A minus B? See the value here. So all of these sets intersection this. So is there any element that is common between this and this? This one here is this. Then C is this. Please check any common element. What and what? 12 and 18. Good. This becomes, excuse me, becomes 12, 18. All right. This one here, right? IX. Okay, let me clean up. IX. So IX, what do I have here? A minus C prime. union B. In some instances, some of the things you're asked to get, their initials are not even in the question, like they've not been solved. For instance, if you ask to find this is simply this one here against this one here. First things first, do I have a value for A minus C prime? Does it exist? Is it here? For me to get A minus C prime, I must first of all get A minus C. Because A minus C prime tells you those elements in the universal set, not in A minus C. So first things first, let's find A minus C. A minus C is equal to, this means elements in A, not in C. Please check. What do I have in A, not in C? Hold on. I have 10. What again? I have 14. Observe that 12 is in A and C. I won't take it. What again there? 14, 16. Okay. 12, 14, 16, right? 12, 14. Hold on now. Okay, 12 is here. 10, 14, 16. Thank you. That's 10, 14, 16. All right. Having gotten this, my next task, now see there's a prime here. Let's now get the prime. Say A minus C prime. What does this mean? The prime means those elements in the universal set, not in A minus C. This is A minus C. This is universal set. What do I have here that's not here? First things first, 10 is here and is here. I won't count it. All right. I have 11, 12, 13, 15. I will omit 14 since it's there. I will omit 16 since it's there. 17, 18. That's all right. All right. With this one here, I have now got the value of all of this. I am still not done, because with this value now, I will now, in quote, unionize it with B. So this value, union B. What does union mean? Union means what there? A combination of what there? Elements without repetition. So I'm saying combine the elements in this with those in B. Don't repeat. Then I'll have that A minus C prime, combine it with B. So it becomes a combination of this one and B. Combine these two, do not repeat. What do you have there? I have, 11, 12, with B, 13, 15, 17, so you combine 18. 18, good. So that's your answer. All right, I'll do one last one. All right, should I finish it? All right, what's the next one there? X. X is simply A union, I'll be a bit faster now. A union C intersection B intersection C. Right, let's get that one done. Of course, please check. Do I have a value for A intersection C? No value. So let me first of all find this. So do I have a value for A union C? Is it available here? No. So let's get A union C. A union C. For union, I'm combining without repetition. Combine the elements in A and C without repetition. What do you have there? So combine in A and C. I'm combining the elements in these two. Becomes 10, 12, 14, 15, 16, 18. So I have 10, 12, 14, 16, 15. 15. Any 16? A and C. 10, 12, 14, 15, 16, 18. 15, 16, 18. I've gotten this man here. Let's now get this one here. B intersection C. B intersection. Intersection, what they have in common between B and C? What do you have there? 15. Just 15, right? All right. That gives you 15. Okay. Let's now solve the question. I want to clean this, please. All right. So we'll now have that A union C intersection of B intersection C is equal to, so I'm doing intersection, what they have in common between this and this. Please check what do you have in common? 15. That's equal to 15. So you have this. I've cleaned it. What's the next question there? This is X. XI. What's 11? A to power C. Minus this. Okay. Do we have A complement already? No, we don't. Let's get A complement. A complement simply refers to, what's A complement? Those elements in what there? Universal set, not in what there? A. Look at this and this. What do I have universal set that I don't have here? Starts from, sorry, excuse me. 11, 13, 15, 17. So there I have 11, it's not here. I have 13, it's not here. I skip 12 because it's here. I have 14, it's here, I'll skip it. I have 15, it's not here, I've included it. I have 16, it's here, I'll skip it. I have 17, it's not here, you include it. I have 18, it's here, I'll skip it. I have 19, it's not here, I'll include it. 19. This man has been dealt with. B union. B is already here. No stress. Union should not be a problem. Do I have C prime? C prime. What does C prime mean? C prime means elements in universal set, not in C. What do I have here that I don't have here? 10, 11. So I'm having this as 10, 11. 12 is here and here. Skip it. 13 is here, it's not here. 14 is here, it's not here. So I'll bring down 13, I'll bring down 14. 15 is here and here, skip it. 16 is here, it's not here. Bring down 16. 17 is here and here, skip it. 18 is here, it's not here. Bring down 18. Sorry. Where am I? 15. I've already taken the 14. 15 is here and is here. I'll skip it. 16 is here. It's not here. Bring 16. So I'll take 16. 17 is here. It's not here. Take it down. 17. 18 is here. It's here. I'll leave it out. 19 is here. It's not here. Bring down 19. All right. So far, so good. I've got this value. So far, so good. I've got this value. Now, all I have to do is start to get the value of what there? B union C prime. What is B union C prime? B union C prime means combine all the elements in B and C prime. So if I combine them without repetition, what do I have there? See, B and C prime, there's 10. So I'll bring down 10. So I have 10, 11, 11, without repetition, 11, 13, 13, without repetition, 13, 14, okay, 14, 15, okay, put again there, you have 16 here, so 16, what else? 17, 17, so let me clean this part, please. $16, 17. What else? 19. All right. Having got this and this, I can now do their difference. In essence, A complement minus, in brackets, B union C prime. What this means are, get the elements in A complement, not in B union C prime. What element do you have here? That's this that you do not have here. What do you have there? 11 is here, it's here, okay? 13 is here, it's here, okay? 15 is here, it's here, okay? 17 is here, it's here, okay? 19 is here, it's here. So it becomes what? How do you write it? Becomes an empty set. There is no it's in there. Becomes an empty set. I'll do just one more. You go figure out the rest. I'll do just one more. You go figure out the rest, please. So which one should I do next? This is 11. Which should I do next? 12. You can do the disjoint. What's 13? So I'll do 13. Since I've not done disjoint, I'll do 13. And then you go figure out the other ones. I think I've done enough. What's 13? So you go do 12. Let me do 13. Please read that. What do you have there? Is A this and disjoint? That's the question. So first things first, get A slash B. We said A slash B is equal to what there? A minus B. Please, have you already solved for A minus B? Have you solved for it before now? Yes. Okay, we have. Okay, please check. Give me the value. Hold on. Check, give me value. 10, 12, 14, 16, 18. That's all? Okay. Have you got for B minus A before? Okay, so let's get B slash A, and that's equal to B minus A. All right, let's look at this. B minus A simply refers to elements in B, not in A. What do you have in B that you don't have in A? That gives you 11, 13, it's here, it's not here. 15, it's here, it's not here. 17, it's here, it's not here. 19, it's here, it's not here. All right. So are they disjoint? How do you prove they are disjoint? And so what do you put? How do you put it in set mathematical statement? What do you say? If they have nothing in common, what's the mathematical representation? Yes, but they're what? No, that's not it. Yes. No. Huh? What? No. Huh? No, now. No, now. We've just seen that they are disjoint. So how do you put it? What can you figure it out? How do you put it in set mathematical term? What do you say? Huh? $5. What do you say? Yes. Me, I don't lose. Me, I don't lose. Me, I don't lose. Yes. Ah, chairman. Chairman. $5 going. Yes. Correct. That's it. That's it. So I owe you $5 after now, okay? For the class. That's it. So you have $5 after class, please. So listen. It's simple. If they are disjoint, it means they have no element in common. So what? So it means that their what there? Intersection is equal to what there? 0, empty set. That's it. Yeah? Observe that A slash B intersection B slash A is equal to what there? Empty set. So you now say, since this intersection this equal to empty set, the sets are disjoint. That's it. That's it. So everything I will tell you, think. $5 is gone. One more five, I mean two more $5 remaining for someone to win it. And for you. All right, I think we've done quite some stuffs. Hang on. This is 5, this is let's say 2 o'clock. So go on break, we'll be back by 2:30. That's about 36 minutes. We'll be back by 2:30. Please keep the time. 2:30, we'll look at Venn diagram. By 4 p.m., you're closing, please. So let's go on break, please. Come on, ask a question, please.